So our last reaction for this section is the reduction reaction. In this reaction, we're going to increase our number of CH bonds and decrease our number of CO bonds. So how I like to remember this is reductions reduce the number of bonds to oxygens with or CH bonds. So reductions reduce the number of bonds to oxygen specifically from carbon. So there's kind of two ways to think of this. You can either think of it as the exact opposite of oxidations. It's the same process, but the other way. Or you can also recall hydrogenation reactions where we took an alkene and added hydrogen across that double bond with a catalyst of some sort, a metal catalyst. So we went from an alkene to an alkane. So reductions are the same, but now we're talking about a CO double bond instead of a carbon-carbon double bond. So for example, if we had this molecule here, and we add hydrogen to do the reduction of H2, we need our same catalyst, so we can have platinum, palladium, or nickel. And we're going to have a addition of a hydrogen on either side of that double bond. So I'm going to draw my black parts the same, minus my double bond, and then we have hydrogen added to either side. Put a purple one here to show which one's leaving. Okay, so let's try this. The exact opposite of oxidation or a similar reaction to hydrogenation, but with different atoms. So we have this aldehyde here, and we have hydrogen with a platinum catalyst. So I know that this double bond here, this bond here is going to be what is broken in order to add our hydrogen atoms. So I'm going to draw out my carbons without that double bond, and then add in hydrogen where that double bond was to each side. So again, these hydrogens on the carbon are not necessary to draw. You do need to draw the hydrogen off of the oxygen. But the two here, these two, you don't have to draw. They are implied. I am drawing them for clarity right now. Okay, and then we can also do ketones. So the same deal. We have this double bond is going to interact with hydrogen and our catalyst. We're going to draw our same framework, remove our double bond, and replace it with our two hydrogens. Okay, let's do some practice for these. So take a moment, try these on your own, and then I'm going to go through the answers now. Okay, so I have this double bond again. We're going to add hydrogen across it, a hydrogen on either side. So I'm going to draw the same carbon framework, my bond to my oxygen, and then put a hydrogen on either side. That is now the reduced form of cyclobutanone, which is just cyclobutanol. Okay, and then our second one down here, we have our double bond again. I'm going to highlight it, draw our same carbon chain, and then add our hydrogens. Now we have our alcohol. So that is reduction reactions. Please practice this and do those practice worksheets that I'm going to give you guys, and make sure you really understand this and really are able to look at the reagents and figure out what the product is going to be.